Wow, that pop quiz is so hard.
Wait, what'd you get on number 3?
Oh, I got 6.
Guys, you can't talk about the quiz, man.
I got 2x. What?
Let's talk about how Katie Parks was in Campus Update. She spun a basketball. She also said that Candy's retarded anymore. We're gonna have some words with her.
Looks like somebody has a bone to pick with Katie. All right, here we go. Example 2. And yeah, you know, we're gonna have breakfast without you guys.
Yeah.
Okay, example 2. Find all values of x for which h of x equals to the third index or the third root of 3x minus 6 plus 5 is differentiable. And is this function continuous? By the way, what's the definition of differentiable? What does it mean? A function is differentiable if it's continuous and if what? Yes, you have a derivative, right? So by the way, what's the parent function for your h of x? What's your parent function there? Algebra 2 review.
F of x is equal to q root of x.
Right, q root of x, perfect. It looks like this. 2, right? Let's review transformations. How do you, if I give you h of x equals to third root of 3x minus 6 plus 5, what's the transformation there? What do you factor? You factor out 3. What's left?
X minus 2.
Good. Okay. So 3 inside, what kind of transformation is that? Vertical, I'm sorry, horizontal? Compression. Factor of a third. Okay. X minus 2, so that 2 value is what? Right or left? Right. Right. 2 units. Then you have a 5 on the outside. What is that? Up.
Vertical.
Yep, vertical translation. Up 5. Okay. So those are review really quickly of your transformations. We did talk about the third root before. Okay. Where do you think the problem location is? What location of x?
0.
0. On the parent. But that's not my problem anymore because when I plug in 0, I'm fine. 0 times 3 is 0 minus 6, third root of 6 plus 5. I have no issue there. So what's our problem here for our h of x? 2. Because it used to be 0, but now we translated 2 units to the right. So the problem is when x equals 2. Because that's why transformation is important. So the problem is really when x equals to 2. Okay, so problem, question mark, at x equals to 2. How do we know what kind of problem? By the way, we have to answer this really quickly. Is this function continuous? Yes, it is continuous. Yes, it is. Yes, h of x is continuous. If it's continuous, does it mean that it's differentiable everywhere? No. Okay, so we have to prove that it may or may not be differentiable at our location of x equals to 2. All right, this is where we use left hand and right hand derivative. Let's start with what side? Left, sounds great. Left. Limit as h approaches 0 from the left. Formula says f of a plus h minus f of a all divided by h. What's your a value? What's your a value? 2. So h approaches 0 from the left. F of 2 plus h. Did we figure out what f of 2 is? Minus f of 2. What's f of 2? 5? Okay. 5. Okay, so let's see. F of 2 equals 2 times 3 is 6, right? 6 minus 6 is 0, so it's just 5. Beautiful. Let's plug it in. So limits as h approaches 0 from the left. How do we plug in 2 plus h? Because I need to find f of 2 plus h. How do we plug that in? Yeah, substitute for x. The third root under the radical, 3 times 2 plus h under the radical still, minus 6 outside of the radical, plus 5, right? Oh yeah, that's a 3. Sorry, that's a funky looking 3. Okay. Then I need to minus f of a, and we know that f of a is what? 5. All over h. Can I cancel out the 2 5s? Yep. What do you want to do next? Simplify. It's under the radical. So limits as h approaches 0 from the left. Under the radical, let's see what you got. 6 plus 3h minus 6. Can I cancel out the 6's? Yeah. So those two guys are gone. It's still all divisible by h. So what's left under the radical? Yeah. Just third index of 3h. But would you agree that third index of 3h is the same thing as writing to the power 1/3, just like that? So now what do? Subtract, yeah. So when you have, I'm sorry, this is coming from the left. I need to add in 0 from the left. Would you agree that's the same thing as saying, okay, well, third root of 3, h to the 1/3. Are those the same? Writing it like that. Yep. So subtract. Let's do it. Limits as h approaches 0 coming from the left. Third index of 3 is on the top. On the bottom, what do you have now? h to the 2/3. Okay. And remember, you should be able to go forward and backward from radical to exponents. Okay. So this is really third root of 3. Would that be the same as writing like that? Perfect. Now, as h approaches 0, coming from the left, what value should we pick? Negative 0.0000? Square that for me. Positive, smaller, right? And the third root of that, still small or very big? Very, very small. Positive small or negative small? Positive small. So third root of 3 divided by positive small. What is that going to come out? Infinity. A positive infinity. So that's left-hand derivative. Now we are going to also do the right-hand derivative. Right-hand derivative, I'm going to jump all of the algebraic is exactly the same until here. Yes or no? Yep, so I'm going to jump all the way there. The limit as h approaches 0 from the right of third root of 3 all divided by third root of h squared. What's happening to the right-hand derivative? It's the same. Why is this question the same? Everything square is always what? Positive. Okay. So this is h squared. So it doesn't matter if you pick a negative small value or positive value. When you square it, it's always positive. So this is positive infinity. Now look at all the 4 choices of your non-differentiability and tell me, which one does this belong to? Which one of those 4 choices has a vertical tangent? Therefore, there is a vertical tangent at where? Yep. Tangent at x equals to 2. Okay, we proved it. A vertical tangent is when the limits both either go to infinity or both go to negative infinity. Okay. So a vertical tangent means it's not differentiable. Does that make sense? Okay. It's continuous, it's just not differentiable. Okay, we're going to do a couple more proofs just like that, okay? Compare the right-hand and left-hand derivatives of the function below. Show that this function is not differentiable at the point. So did they tell you already that this is not differentiable? Yes. So please don't tell me it's just not differentiable. You have to show it. How do you show it? How do you show that it's not? It said it's not, but how do you show it? Do the same thing. Do you want to start with left or right? Left. Okay. Keep it consistent. To the left, to the left. Listen, there's only like 10 of you here. You might as well have fun.
Right.
We're gonna have fun when they're gone.
Yes.
Yeah. Party.
That's what my kids will like to say. Like, Dad let us eat ice cream. My kid told me the other day, Mom, you shouldn't be like so much like a math teacher. I was like, what does that mean? It's like, you're so strict. I'm like, yeah. All right, tell me what you write. This is a test question. How would you start? Limit. Guys, do not leave the limit at home. Write limit at least once. Yes, I won't give you any partial credit. Okay? You don't have to write it every time, but I do need to see it at least once at the very beginning so I know that you're using derivative. All right, limit of f of what? A plus h minus f of a all over h. All right, what's your a value? 1. Very good. So let's go. Limit as h approaches 0 from the left, f of 1 plus h minus f of 1, again, all over h. Here's the reason why if you just write this without the limit, is that even a derivative? No. That's like a y2 minus y1, right? So that's not, okay, the definition. So write it at least once. All right, now what? What are you gonna do? Plug it in? What are you gonna plug in for 1 plus h? Which piece? Yeah, the top piece, right? So limit as h approaches 0 from the left. We're gonna write 2 minus, what's f of 1 always? 2 all over h. So what's your slope? 0. And now let's look at it to make sense. Can you see if I were to graph this out? What kind of graph is that? Yeah, it's a flat line. A flat line will always have a slope of what? 0. So that should always connect. Now we're going to the right. To the right, to the right. Okay. Same definition, except I'm just going to write h approaches. Limits as h approaches. Okay. Again, it's f of 1 plus h minus f of 1 all over h. F of 1, does that ever change? No, that's always 2 in this question. Which piece are you going to plug 1 plus into? 2. Okay, so limit as h approaches 0 from the right is 2 times 1 plus h minus 2 all over h. Simplify that. That's really 2 minus 2h. I'm sorry, 2 plus 2h. Okay, so limit as h approaches 0, 2 plus 2h minus 2 all over h. When I cross out a lot of stuff, what's left over? 2 is the slope. Okay, those of you who are in physics, you can check pretty quickly, right? Now, those who are not, just trust your algebra skills. Based on your definition, we already told you that it's not differentiable at 1. But what kind? Therefore, Trey says a corner, question mark? Is there a corner? Read the definition of corner. Corner says what? Oh, are they different? Yeah, they exist. They're different. So there is a corner at, yeah, there is a corner at x equals to uno. Yes, Trey, you want to say it?
Yes, I got that right.
Oh my gosh. Can you imagine? This is like the smallest class you've probably ever been in.
I like it.
Okay, example 4. We're going to prove it again. Should I give you a head start to see if you can handle it?
Yeah.
It tells you that there is a location that's non-differentiable. What location is that? At x equals to 0. All right, do the left and then do the right, and I'll catch up. How about that? If it's wrong, that's okay. That's why we're just taking notes. Talk it out, you know? Pretend you like each other for the next few more minutes.
I'm just gonna be honest with you, David, I don't like you bigger words.
What is H approaching?
0.
0. What's your A value? Also 0. Okay, so that means this is left, which is f of h. Well, what happened when you plug in 0? What's f of 0? 0 to the 4/5 power is 0. Okay, so that means when you plug in h, you got limits as h approaches 0 from the left. Would you agree that that's just h raised to the power 4/5 divided by h? When you're subtracting the exponents, what's left? Yeah, 1 over h to the 1/5. Okay, and some of you don't have to write it. Can I write it as a radical if you like radicals better? Yeah, when it's a rational exponent, write whatever you want. Now, as h approaches 0 from the left, what value are you going to choose? Negative, right? 0.001, or whatever negative value you want to pick. Fifth root. Negative. 1 divided by a negative small number is a negative large number. So this is heading towards a negative infinity. Now on the right side, you can skip a lot all the way to here. Could I just skip all the way to there? Yeah, skip all the way to there. So limits as h approaches 0 from the right of 1 over 5th root of h. What happened when you pick positive 0.0001? Then it's a positive infinity. Now look at your rules. Which one of those 4 that we are going to write for our, okay, therefore there is a cos at x equals to 0. Oh yeah, C-U-S-P, I know. That's, my handwriting is terrible. Okay, so summary of the 4 non-differentiable in your own words. I don't want it copy and paste from our original definition. Okay, what's the first non-differentiability? What was it called and how do we find it? Corner. In your own words, how do we decide if it's a corner or not?
Left and right limits are different.
The left and right, not limit. When you use limit, it can be derivative. Left and right derivatives. Corner, it can, yep, it's continuous. But left and right derivatives are different.
Can you solve a corner if it's not continuous at that point?
Then it just be not discontinuity. Okay, so next culprit of non-differentiability. What was the next one? Cuss, okay. What, in your own words, that is. How do we decide that This is a cusp. What is it? So are you saying that infinities are opposite? Okay, so opposite infinities, is that what you're saying? Opposite infinities. What's your third? Vertical tangent, okay. Okay, in your own words, what do you want to say? What is it? Same infinities, okay? Just one, so both sides, right? Okay, so same infinities. And then last one, discontinuity is right. How would you decide if it's a discontinuity?
If one doesn't exist,
I can't, you're mumbling.
one of the derivatives doesn't exist.
Yeah, one, or at least one. Would you guys agree? Okay, how about we say at least one? At least one derivative does not exist. All right, that's an egg roll for today.